Hi, welcome to DTKSS. In this current session, we are going to discuss about Azure Queue Storage. The Azure Queue Storage is a service used for storing large number of messages, and these particular messages we can access anywhere in the world through authenticated calls using HTTP or HTTPS. So when you are creating a message in the queue, the maximum size of message should be 64 KB, and the number of messages you can send 20,000 per second per single storage account, and these particular messages will expire in 7 days. So now we'll see that how this Azure storage queue will work. For example, we consider a scenario that a news channel publishing the news into their channel website. So in general, journalists will go ground level to collect the news and write their articles through different devices like mobile app or website or any other devices. So when the journalists submit their articles through the different devices, those messages will be stored at the Azure queue. From this queue, we can able to read the messages submitted by different resources like different journalists. We can read that and publish into the portal. So that particular news they can read by the public. Now we see that different scenarios why we need the Azure Queue Storage. Queue based load leveling pattern, competing consumers pattern, and the retry pattern. Now we see that queue based load leveling pattern. For example, we consider a scenario that we have created an application, and this particular application will help to allow to read the data or write the data or update the data or delete the data. So a set of users is trying to access this particular application. When they access, the data will be fetched from the database. So consider a scenario that the number of users has been increased, the application using users has been increased, then we have to scale the application to give the better performance. So for the scenario, we have scaled our web application to two servers, and both servers is pointing to single database. So when the users is increased and the number of requests writing to the database has been increased, after certain level, this database will be goes down or will crash entirely. So how we can reduce the load to the database, the number of requests trying to access the database at the same time, how we can reduce. But I don't want to, here we need to consider is, I don't want to create the multiple databases to write the data into the database. I want to maintain a single database. I want to escalate this, I want to auto scale these web applications, and the users should get the better performance. How we can achieve is, we can implement the queue. So what will happen is, when users trying to access this web application, whatever the data they are modifying, it will write into the queue, and that particular data will be processed by Azure functions, will be inserted into the database. So by using of this approach, we can achieve the reducing the load at the database. So meaning all the request is not directly talking to the database and not writing into the database. It's right into the queue. This particular Azure function will pick those messages one by one in sequential and write into the database. So there is no load to the database. And one more scenario is competing the consumer's pattern. For example, number of users is trying to write the data into the queues. but we need to process these queues into as early as possible. So how we can achieve this is, in without the queues we cannot achieve that. What will happen when the user try to access the data through web app, and they will write the data into the queue. So we are doing auto scaling the Azure functions. So what will happen is that the latency will be very low and will get the high performance, because of these Azure functions will pick those messages in parallel. So when there is a heavy load, we will increase auto scale these Azure functions, and the messages will be processed very quickly, and the user will get the response quickly. So this is one of the approach we can achieve through the Azure queues, meaning you are writing the multiple queues, and that queues will be processed through auto scaling and writing into the database and giving the response to the user very quickly. And one more important thing is retry pattern. So in this approach, what we are doing is, for example, consider you are accessing a web application. You are trying to read the data. So you send the request to read the message from the queue. Some reasons, maybe network failure or whatever the some reasons, you did not receive the response, whatever the request you try to read the message. So you can retry to read that message. So this message will not lost when you are requesting. It will not lost. It will be still be there. Still, it will be there in the queue. So you can re-request that particular message, and you will get the response. So there is no data loss. So in these three patterns we have covered why it is required the Azure queue. One is queue based load leveling pattern. So that is, instead of getting load the database, we can implement a queue. From the queue you can able to process the database and reduce the load to the database when there is a multiple users is accessing the database directly, accessing the system directly. And second approach is like competing consumers pattern, meaning when the multiple users are using the system, you want to give a response very quickly. You want to process their request as early as possible. So we are auto scaling the functions based on the data we are reading here in the queue. So by the way, they can get the response very quickly, and there is no load to the database as well. And one more is retry pattern. So you can request multiple times if you want to read that particular message multiple times, if the request is not successful in the first time. And what is the advantages of using the queue storage? First thing we must notice that decouple the component. What is meaning of decouple the component? For example, if you consider a scenario, the web application here, the responsibility of web app is submitting the data into the queue. That's it. It is not going to take care entire like inserting into the database. Until that, it will not wait. It will just insert the data into the queue and give the response back to the users. And this particular Azure functions will read the queue and will process that particular messages. So there is no coupling, there is no dependency between the web app and these Azure functions. They are decoupled. And second advantage is built-in resilience. Queue storage helps to make your application scalable and less sensitive to individual component failure. So as we discussed earlier, like web application is just inserting the data into the queue, and the Azure functions is reading the message into the queue and inserting into the database. So there is no dependent. If Azure queue any reason it goes down, I mean the Azure function goes down any of the reason, then there is no impact to the web application. So that's what it is telling, build in resilience. If the part of your architecture goes down, messages are buffered, then naturally picked by other messages processing the nodes, which maintains the integrity of workload. Scale of burst. What is meaning of scale of burst? The application absorbs the unexpected traffic burst, which prevents the servers from being overwhelmed by sudden flood of the request. Monitor the queue length to add the elasticity to your application, and deploy or hibernate additional worker nodes based on the customer demand. So this is the best scenario. For example, when multiple users trying to access our web application, so we want to process that particular request as early as possible to give the response. So we are implementing the auto scaling here, that Azure functions based on the demand. So there is no overwhelmed on the servers, since each request is inserting into the queue, and that based on the request length we are auto scaling these Azure functions and inserting into the database. So there is no delay on processing the request. Based on the load of the queue, these functions will be auto scaling. So that's we are telling the scale of burst. So then one more question will rise, that when we have to choose Azure Queue Storage, there is a lot of queues is there, like a service bus is there, and event hub is there. Among that, when we have to choose this Azure Queue Storage, the first scenario is that application must store over 80 gigabytes of messages in the queue. So this is the first requirement. If your application has a requirement that has to store over 80 gigabytes of messages in the queue, go with the queue storage. Then second scenario is application want to track the progress of processing a message in the queue. So it's useful if the worker processing a message is crashes. For example, any application, any server is processing particular queue message, and some reasons, there will be multiple reasons, some reason that server has been crashed and it is unable to process that particular message. So what will happen, maintaining of that progress, the another worker can use that information to continue from where the prior worker has left off. And third scenario is require a server side logs of all the transactions executed against your queues. So if you need these three scenarios, you can choose Azure Queue Storage. Now we see a demo how we can create a queue storage. So I'll go back to the Azure portal, and here you can see, from this is the, when you log in, you can see this is the page. From there you click on the storage account and you create a storage account and create a new resource group is D2K SS, and I will call this as D2K SS storage account. Then choose LRS review and create. So deployment take a while. Deployment is completed. Go to the resource, and here you can able to see the under data storage account. You can see under data storage, you can see the queues. Create a new queue, D2KSS queue, and OK. So queue has been created successfully. So you can create n number of queues under that storage account. So you can enter D2KSS storage, Q2. So go to the any one queue and add the message, write the message, this is queue storage demo, and see default it is 7 days. You can put never expire. So if you put this, the message will not expire. If you uncheck this particular message will be expire in 7 days, and encode the message body with base 64. So click OK and the message being created. Insertion time, and this is the expiry time. DQ the count, so 0, so meaning we did not read this message, and so it will not delete. All the DQ'd message will be deleted automatically. So this is the how you can able to create the messages, and also you can how you can able to access that messages, like you can use the access keys to integrate with .NET applications. So in the next session, I will discuss about how we can access these keys from .NET Web API. Thank you.